Okay, so this is the key to section 1.2, part 3. All right, so the direction says solve each linear equation. So you notice that and it really should be solve each linear equation. Now, this should have said solve each equation. I should have said each equation because you'll notice that 3 and 4 are not linear equations. So it should have just said solve each linear equation. I mean, the section is titled linear and rational equations, but the first two are linear, and then the 3 and 4 are rational. So I just wanted to make that point. So solve each equation. All right. Now you want to show the work as presented in the notes of the videos, and then write the solutions as integers, fractions reduced, or mixed numbers reduced. Do not use any decimals. And then at the end, I want you to determine if the equation is an identity, a conditional equation, or an inconsistent equation. All right, so let's solve number 1. So the first thing you're going to do, notice, is since I do have parentheses here, I'm going to use a distributive property. So for this one, I'm going to distribute the negative 3. And over here, I'm going to distribute the positive 2. All right, so you got to do the multiplication. So don't say negative 3 plus 2 is a negative 1. And definitely don't say 8x minus 3 is 5x. That's not true. Okay, so you got to do distributive property first. You got to multiply first. Okay, so I get 8x. A negative 3 times x is a negative 3x. A negative 3 times a negative 2 is a positive 6. Equal negative 3. A positive 2 times 2x is a positive 4x. And a positive 2 times a positive 1 is a positive 2. Combining like terms, 8x minus 3x is 5x. And then plus 6 equal over here. A negative 3 and a positive 2 is a negative 1. So I get 4x minus 1. All right, now since this is linear, I can bring all the variables one side, constants to the other, so I'm going to subtract 4x from both sides. And then 5x minus 4x is x, plus 6, equal 4x minus 4x is 0, and I'm left with 0 minus 1 is a negative 1. And then finally, subtracting 6 from both sides, combining like terms, I get x to equal negative 7. So my solution is negative 7. Now the question is this an identity, a conditional equation, or an inconsistent? Since this solution has since this equation has one solution, it's finite, I can count them. Finite, I can count. There's only one. Then this is a conditional equation. So this is a conditional equation. All right. So this equation is true only under the condition that x equals negative 7. Now let's do the next one. So again, same idea. You can distribute the 5. You can distribute the positive 3. And so we get 5 times x is 5x. 5 times a negative 4 is a negative 20. Plus this 4 equal 2x. Distribute the 3. 3 times x is positive 3x. And then 3 times 2 is a positive 6. And then subtract 22. Combining like terms, a negative 20 and a positive 4 is a negative 16. So I get 5x minus 16 equal 2x plus 3x is 5x. 6 minus 22 is a negative, let's see, negative 16. All right, now bring all the variables one side, constants to the other. So subtract 5x. And notice what happens when you subtract 5x. 5x subtract 5x is 0. 0 minus 16 is a negative 16. Equal 5x minus 5x is 0. 0 minus 16 is a negative 16. So at that point, the variable disappeared. There's no longer any variable. So that's where you're going to either get all real numbers or no solution. Well, since a variable disappeared and that statement is a true statement, see, that's a true statement. So those two sides are identical. Now you could have stopped here. See this right here? Where you could recognize that 5x is equal to itself. So those two sides are identical. So you could have stopped here. You didn't have to go any further and indicated that your solution is going to be all real numbers. All real numbers. Now, since, remember I said the word identical, since these two sides are identical, it's going to be an identity. So this is an identity. So here's the word identical. Okay. So conditional equation, you can count the number of solutions. There's only one. Identity, there's an infinite number of solutions. You can't count how many solutions there are because it's all real numbers. You can't count those. All real numbers is just an infinite set of numbers. Okay, now let's go to these rational equations. Now, again, since I do have variables in the denominator, I do want to check for the restrictions. So these denominators are both the same, and I can't factor those. So you can look at these and ask yourself, what makes this 0? Well, 2 makes it 0. So my restriction is x cannot equal 2. But I do have to find the LCD. So the LCD, since those are the same, is just x minus 2. There's your LCD. So I'm going to multiply both sides by the LCD. Now notice this side here, the left side, has two fractions. 5 over x minus 2 and then 1 over 1. So I'm going to put that in parentheses. 5 divided by x minus 2 minus 1. That has to be multiplied by the LCD, and so does the other side. Negative 3 divided by x minus 2. So both those sides have to be multiplied by the LCD. Both those sides have to be multiplied by the LCD. Alright, now here I'm going to distribute. So I'm going to get x minus 2 times the first fraction minus, I'll be careful here, that's minus 1 times x minus 2. It's important that you put x minus 2 in parentheses, because if you did not, you would be saying you're only multiplying x by this negative 1 and not negative 2, and that's incorrect. So negative 2 has to also be multiplied by this negative 1. And then that's going to equal negative 3 over x minus 2 times the LCD. So notice every fraction was multiplied by the LCD. Every fraction here was multiplied by the LCD. You can see this step. Now the next step is to factor out your common factors. So x minus 2, and you're left with 1 times 5 is 5. Okay, over here, you're going to distribute. So negative 1 times x is a negative x. Negative 1 times a negative 2 is a positive 2, equal. And over here, the x minus 2's divide out. And on the other side, you're left with a negative 3 times 1 is a negative 3. Okay, combining like terms, I have negative x. 5 and 2 is 7, equal negative 3. Subtract 7 from both sides. I get negative x equals a negative 10. So I get negative x equals a negative 10. Now remember, negative x means the same thing as negative 1x equals negative 10. So you get x by itself. I'm going to divide both sides by negative 1. Negative 1 divided by negative 1 is 1. 1 times x is x. So I get x to be negative divided by negative is a positive. 10 divided by 1 is 10. And that is not your restriction. So x equal 10 is a solution. Now again, what type of solution? What type of equation this is? Well, this is a conditional equation because it only had a finite number of solutions. In this case, only had one. It's a conditional equation. Okay, now in the next one, again, notice that over here, I've got to, before I find the restrictions, I've got to find the LCD. I've got to factor this denominator. So when I factor this trinomial, and remember, always look to see what these factors are, because it could be that one or both of these factors would be these right here. So x times x, the last sign's positive. That means both these signs in here are the same as be the middle sign. So it'll be both negative. And there are several possibilities for 12. 12 times 1, 2 times 6, 3 times 4. Since these were 3 and 4, let's use them. So let's see if that works. So you gotta just make sure you get that middle sign, that middle term. The outer is a negative 4x, the inner is a negative 3x. When I add them up, I do get negative 7x. So this right here, this trinomial, can be factored as this, which helps because that's what these were. All right, so we said we got to find the restrictions. I need to know what makes this factor right here 0. So notice that 3 minus 3 is 0. So 3 makes this factor 0. Over here, what makes this factor 0? Well, what number subtract 4 is 0? Well, the answer is 4. So I cannot use 4, so that's a restriction. X minus 3 I've already dealt with, X minus 4 I've already dealt with. So I'm done with in terms of restrictions. But I got to find the LCD. So remember, every factor you see has to be in your LCD. So my first factor is X minus 3. There's only one here, none here, so I got to use 1. The next factor I see is an X minus 4. There's 1 here, none here, 1 here, so I must use 1. So there's your LCD. So now I'm going to, just like I did this one, I'm going to do the same thing. Now the left side is just one fraction, so I'm going to not put in parentheses. I'm just going to say the LCD times the first fraction. And go ahead and write this factored part, so that way you can see what factors you can divide out. Equal, now since that's two fractions here, I'm going to put that in parentheses, and I'm going to multiply by the LCD. So put that in parentheses. So 2 over x minus 3 plus 5 divided by x minus 4. Alright, now over here I'm going to distribute, and over here I'm just going to go ahead and factor and divide out. So x minus 3 is divide out, the x minus 4 is divide out, and notice you're left with 1 times 5, which is 5. Over here, so distribute the LCD, so I'm going to get x minus 3 times x minus 4 times the first fraction plus the LCD, x minus 3 times x minus 4 times the second fraction. And then now we're going to reduce. So reduce this. The x minus 3's divide out, and you're going to be left with 2 times x minus 4. Over here, reduce, so x minus 4's divide out, and you'll be left with 5 times x minus 3. So basically you're going to have this. You're going to have 5 equal 2 times x minus 4 plus 5 times 1 is 5 times x minus 3. Alright, so notice I went from a rational equation to a linear equation. Alright, let's go ahead and just get rid of the parentheses. So I'm going to use distributive property. So I get 5 equals 2 times x is 2x, 2 times the negative 4 is a negative 8, a positive 5 times x is a positive 5x, a positive 5 times a negative 3 is a negative 15. Combining like terms, I get 5 equals 2x plus 5 is 7x, a negative 8 and a negative 15 is a negative 23. Alright, adding 23 to both sides, I get 28 equals 7x, 28 equals 7x, and then dividing both sides by 7, I get x to be 4. Alright, so x is 4, and so since x is 4, I look at my restriction, I cannot use it, and that was the only proposed solution. There's only proposed solution, so then I say no solution, or the empty set. And then since there's no solution, you're going to say this is an inconsistent equation. Okay, inconsistent equation. Alright, so that's going to take care of worksheet dealing with section 1.2, part